Hello, my name is Daniel Kevin Siboro, and I will be presenting my poster on the paper titled Assessing Gallium Nitride FET Performance Degradation in Power Amplifiers for Pulsed Radar Systems. And it was written by a number of authors written here, and it was published in IEEE Microwave and Wireless Components Letters, Volume 28, Number 11 on November 2018. The abstract here is directly taken from the paper, and you can read it here. So this paper was written to compare and show how the gallium nitride transistor will perform for a pulse radar system, and this paper in particular will show the performance degradation and power amplifier for the pulse radar system. So in this case, the authors try to find out the actual performance of the gallium nitride transistors in the pulse radar operation by mimicking the power amplifier dynamic power supply operation by using a low frequency load line to fix the thermal and charge traps and measuring the S parameters at microwave frequencies to find the dynamic bias point for the load line. Here we can see the picture for the circuit used by the authors for the experiment. So the results from this experiment can be seen from this graph here and a graph below that I will show later. And the results will show that the drain current will peak at a very small positive voltage for the drain voltage, and it will significantly decrease after that peak to 0 amperes. And similarly, the drain voltage also decreases but gains an increasingly positive gate voltage. And as we can see, there are several lines signifying different large signal operating points for the points used by the authors and for the experiment. And we can see that there is a circle indicated by the authors, and this will be explained in the analysis. And we can also see here that the drain current increases with increasingly positive gate voltage. So the lowering drain current happens due to the fast charge trapping effects, which decreases the amount of charge and decreases the amount of current after a certain amount of drain voltage. And the circle, the black circle from the drain voltage against gate voltage graph, indicates that the experiment was corresponding to a deep class AB operation. And we can also see here another result from the experiment, which is the measurement for the dynamic S parameters S21 and S22 and the static parameter, which is S11. For the S21, the authors also measured for the parameter using a vector network analyzer, which is the line with the thick continuous line. And we can see that it is the highest out of all the other lines, and the other lines are the large signal operating points used by the authors, and we can see that they are all lower than the measured amount from the vector network analyzer. And we can see a similar result with the S22 parameter, where the value measured from the vector network analyzer is different from the value measured using the large signal operating points. In conclusion, the paper tries to show and emulate how a gallium nitride FET would perform in a practical situation, in this case for a pulse radar system, and show how its performance degrades due to dispersion mechanisms and charge trapping. And this was created in hope that other people can take these results in consideration when they're also designing a circuit when they're going to use the gallium nitride transistor. Thank you for listening. God bless you.